And I think we might be live. Let's wait. Make sure everything else logs in. It's been one of those type of days. Let's see. Okay, we're live on Instagram. We should be going live on Facebook. And let's see. And YouTube's up. All right. So everyone's up. Ready to go. So let's cover a few bases before we get into the fun. One, if you're interested in a stock tip, buy Vicks, because I've been battling this cough, and I think I cleared out all the Dayquil and all the Vicks Vapor Rub and Sucrets and tea. So honey, lemon. I might cough during this because I've been battling this dry cough, and especially when I start getting amped, I cough a lot. And we're talking about winter, so most likely I'll get amped. And then you ask questions, and then someone will bring up the GFS. So prepare for a coughing fit at some point. I know it. But I got tea at hand. I'm ready to hold it off, see what happens. We'll see. But I've been battling this cough for almost a week and a half. I'm done with the cold, but the dry cough will not leave. It's evil. I blame it on the Dodgers. There we go. So there's that. Other thing, we had an issue with the website earlier, and I do apologize to some people who are having an issue with logging into the website, as I was having issues logging into the website. It's a server issue that should be up and running, but if anyone asks, clear everything out, because we had to redirect to a different server or something technical like that. This is why I pay people to handle this stuff. So that might be why it may be taking a little bit longer for you to log in. That will fade away as everything redirects to the proper servers and all that jazz. With that said, let's talk about the winter. This winter forecast, as all of them have been for several years, has been very difficult. And I think the first thing we need to touch on is the fact that volatility is high and chaos is high. And I think that it would be an error to talk about seasonal forecasting if we didn't talk about the tropics. The tropical Atlantic. Well, I don't think we're getting 30 storms this year, guys. Maybe touching 20. We'll see what happens in November. Certainly above normal, slightly above normal, absolutely. There's our first shot of tea. But it certainly wasn't the season that some were suggesting. Even myself. Okay, I was thinking, okay, 20, 21 storms. I was right about the major hurricanes. And that is in testament to how warm the Atlantic is. Okay, so the warmth of the Atlantic, that helps you understand the potential for intensity, but it doesn't give you the number. That factor, how many storms we get, is more about the development of La Nina. Now, currently, we're dead as a doornail for the next 7 days. We got nothing going on. And part of that is because, look down here. See that? See here. Let me zoom in on this here. You see? See how these clouds are moving like this? That's vertical wind shear. When you have La Nina in place, that really doesn't show up all that much, especially around the intertropical convergence zone. Why am I bringing this up? Well, if you made errors with the seasonal forecast with the tropics, you might want to take a step back and reconsider before you copy-paste La Nina, right? Because we're not dealing with the same ballgame here. Now, there are several reasons why that might be the case. You could talk about Tonga, with the water vapor interrupting the stratospheric circulation, maybe creating some havoc with convection. You could certainly bring up climate change, warmer waters. Okay, so maybe that's altering things a bit. But what you don't want to do is lock yourself into just one thing and kind of just tunnel yourself, give yourself tunnel vision on only one factor. So you kind of want to step back and say, okay, how do I handle what happened in the summer? Because in the summer, we did not have a traditional La Nina. Well, for one, our La Nina took some time to develop. Really did. Now, there are some out there who want to make an adjustment with La Nina and say, because of global warming, we're going to adjust the temperature so it's really a moderate La Nina. That doesn't work for me, okay? The reason why it doesn't work for me is that while you can adjust the temperatures all you want, what matters is not your statistics. What matters is forcing. You can have all the statistics in the world. If they don't match up to atmospheric forcing, it doesn't matter. So what type of forcing are we dealing with? Well, as you know, I like to look at the SOI, which we'll look at in a moment. But let's just say it hasn't exactly been very impressive. In fact, it's been very, very unimpressive. But we're seeing La Nina starting to get its act together here, starting to organize here. And I would call this central to east base. Certainly not west base. Certainly not focusing around Nino 3. Nino 4. In fact, it's pretty warm. And in fact, the subsurface in this region is pretty warm. And most of your cold water is focused over here. So why is that important? Well, when you have a lot of your cold water focused here, you tend to have your convection focused here. So this would support MJO phases 7, 8, 1, sometimes 2, depending on the time of year. And we'll talk about how important that is. We got a lot of stuff to cover here. And I will get to all your questions and go from there. Of course, all premium members, you get all your questions. But I'm not answering anything about the Yankees and the Dodgers because it hurts too much. So just wanted to make that very clear. But in this environment, this is a weak east central based La Nina with a negative PDO signal. Now, what's interesting this year is that our warm pool has returned to the south of our cold pool. People used to call this the blob. Not really. It's just a part of the PDO cycle. And of course, you have very warm water here, which has been enhanced. Let's face it, it has. This is very impressive warm water. So typically when you have this set up, you can support a stronger support for a more powerful ridge in the Gulf of Alaska at times. And so the Pacific sea surface temperatures tells me a story of a very weak La Nina support with a negative PDO with a signal here that would support a stronger ridge here in the Gulf of Alaska as we move on through the winter. More of a trough around the Aleutians. And with a stronger ridge, better potential for polar and Arctic air masses to drop south from northern Canada into the eastern two-thirds of the United States. Typically, when you're dealing with La Ninas in this type of setup, that focus in the air masses is really towards the plains, and it bleeds to the east. So if you're thinking, hey, that sounds like Arctic cold air into the mid-Atlantic, not exactly. Typically what happens is that you get basically a blue norther dropping through Texas, in which then once again, somehow they're unprepared and everyone loses power, even though this is something that isn't new. And then it bleeds to the east towards the mid-Atlantic, and you set up this very robust storm track. Meanwhile, in the Atlantic, very warm waters. Now, typically with a positive AMO, you end up with a positive NAO signal. But this one's a little funky. You see, typically with a positive AMO, you get a cold body of water here. It's not even cold. It's lukewarm compared to the rest of the Atlantic. So it doesn't produce the same type of thermal gradient, and it doesn't set up the same type of forcing mechanisms that you would look at in the 80s and 90s and 2000s. Is this a factor of climate change? Well, it certainly stands out as one. But I do want to make it clear, despite what some people think, the AMOC is doing fine, and our Gulf Stream is as strong as ever. So that won't be a concern. Gulf Stream is going to help to enhance some of these storms off the Mid-Atlantic coast, though. This signal to me tells me, when the stratospheric environment and the upper tropospheric environment is favorable for a negative NAO, this won't inhibit it. If there's no support in the upper level environment, then you won't get a negative NAO. So this tells me you got more of a transient NAO, transient high latitude blocking. If you're looking for a weather pattern where it just sticks and lasts for 6 weeks, that's not going to be this winter. This winter is going to be, you get a pattern, lasts for about a week or two, another new pattern changes, and then another one follows after that. So the declarations of winter wonderland all year, or winter canceled all winter, is going to fail. You're going to have waves of warmth and waves of cold and stormy conditions in the way that this sea surface temperature anomaly setup is evolving here. But of course, we don't just follow the sea surface temperature anomalies. As I said beforehand, the SOI has been, less than impressive. Now, for some of you guys that don't know what the SOI is, basically, this is a great way to measure a lot of the forcing mechanisms in the atmosphere. When they're talking about La Nina and El Nino, part of that is the measurement of the different pressures in the atmosphere in the Pacific. So the reason why I like using this is because this gives me a direct measure of how much the sea surface temperature gradient, thus the mass gradient, and thus the wind movement, is impacting pressure. If I understand the pressure, then I understand development of convection. If I understand the development of convection, then I understand the development and the influence on the atmosphere in our jet streams. Some people use this religiously. Some people ignore it. I prefer to use it. I don't trust it 100%. Like, if I see one factor, I don't just throw out the forecast. But it gives me a good idea of what is going on in this part of the forecast. And when I say this part, when you're doing a seasonal forecast, if all you do is focus on tropical forcing and ignore everything else, you're missing 2/3 of the forecast. So this gives me a part of what we're seeing. And what we're seeing here is that the monthly and seasonal values are weak. They're weak. Look, an SOI at 2.86 is not going to cut it. Anyone running around calling this a moderate La Nina, dude, you don't have the forcing for it. So when I look at that, I say, okay, this is clearly very, very weak. It's almost near neutral. Now, what is this part? These bar graphs? This is the daily contribution. So, excuse me. When you have negative contributions like this value here, this supports more convection around the date line. When you have these positive contributions right here, less convection, very quiet on the East Coast. It works better in the winter than any other season. But this basically gives me my storm signal. Now, it's not a 1-to-1 ratio. It's not like where it goes negative and then you get a storm the next day. There's a bit of a lag time, but you can see where the pattern's evolving based on the evolution of tropical convection. So in the winter, every time this starts going towards a negative state, we have to watch the East Coast for storm genesis. When it goes to a positive state, generally high pressure, right? So again, it's not a 1-to-1 ratio, but it gives you a good idea on the tropical convection forcing mechanisms involved in the atmosphere. And as you can see here, weak La Nina influence. So with a weak La Nina, we have to keep an eye on our MJO. And this is where the chaos begins. Because the MJO forecast is really trustworthy 7 to 10 days. You can go out to 15 days. If you're using the 15-day forecast like what we have here, my suggestion is to be general with it. Do not make declarations that there definitely will be a storm. But what this tells me, for example, for early November, is that there's a better chance for rainfall. And God, do we need it around here, right? So as we move through the cold season months, you want to keep an eye when you move into phase 8, 1, and 2. Those are typically your stormier MJO periods during a La Nina. When you're in phases 3, 4, 5, and you can even throw in 6, typically that's when it's going to be pretty quiet around here. Now, the MJO factor was a major factor and major influence in our weather pattern during the summer. La Nina was really, really struggling, barely even in development. And our MJO was locked in phases 4 and 5 for the most part. These phases suppress tropical development in the Atlantic. Why are we talking about tropical development in the Atlantic with a winter forecast? Because it gives us an idea of just how powerful the MJO can be with a weak end-snow signal. Many forecasts, including my own, with the tropical Atlantic was based on the idea that La Nina was going to gain ground. In fact, back in April, the idea was La Nina was going to be locked in and maybe heading towards a moderate La Nina by June. Well, that clearly didn't happen, right? So without that state, you didn't get the monster development that we were expecting in terms of the number of storms. And that's why you saw August relatively quiet. And same thing with last September. When did we really peak into action? Well, you can see right here. During this time period, right here. See where it shot through 7, kind of went through a neutral state, and 8 and 1. That's when our tropical Atlantic became very active. And that's also when we started to see more East Coast cyclogenesis. It's just that, well, it was summer and the wavelengths were a bit off. So you really couldn't develop a lot of rainfall. But the potential was there. So what can we learn from this? What can we learn from the tropical Atlantic forecast and the winter forecast now? How do we apply that? Well, we have to understand that the tropical forcing here is going to be influenced significantly by this by these MJO phases. And this is what's going to create high volatility in the subtropical jet stream, which is going to remain active. It's going to remain very active this year. So typically with a La Nina, you have a weak subtropical jet stream, not a lot of moisture involved. You have a ridge that dominates over the Bahamas and the southeastern United States. This year, that's going to be displaced. And you're going to see more robust disturbances coming out of the southern Mississippi, lower Mississippi, and Tennessee river valleys. Excuse me. Heading towards the mid-Atlantic. So whenever we're in these phases here, heads up. When we're in these phases, go on vacation. It'll be fine. The other factor we have to consider is what's going on in the stratosphere. Now, we've been talking about this for the past couple of weeks with some of you who have been here for a while. The QBO is westerly. What does that mean for us? Well, first of all, what is the QBO? The QBO, excuse me. Yeah, sorry about that. The QBO is a measure of the winds in the stratosphere at 30 and 50 millibars. When it's easterly or negative, that works against the polar vortex. When it's westerly or positive, that's when it enhances the polar vortex. So you're more likely to have a stronger polar vortex. when you have a westerly phase. And your high latitude blocking tends to be, I would say, limited, transient, but not impossible. So what do I mean by that? You can get a strong negative NAO block in this environment, but it's more likely to get broken down faster and then rebound. So you get a lot of situations where you have a negative NAO dip, goes back to positive, drops back towards negative. Very, very much variable. So we know we have that. But this is a demonstration of how a polar vortex is forming here. And I found something very interesting here. Let me zoom in. Watch this thing circulate. Notice the upper stratosphere, very well organized. Very much influenced by QBO. Very strong. Locked in. Notice the lower ends, though. Disrupted. Not as well organized. Warped. Stretched. Why? Could it be that, hey, look, the polar vortex is just starting to develop? Okay. Could be a factor. But you would think with the positive QBO, you would see a more significant development, a more robust development. We've seen above normal snowfall in Siberia, below normal sea ice, which we'll go over more. But what is the real factor that stands out? Well, let's take a look at the stratospheric temperatures. So this is a chart of the stratospheric temperatures at 1 millibar. So to consider that, that's up here. Very strong polar vortex. Well, look at that. Very cold stratospheric temperatures. This makes a lot of sense. Why does it make a lot of sense? Well, the sun is very active. The more active, we have actually reached a solar max. And what that means is that you have a lot of energy impacting the Earth's atmosphere. It tends to help to break up ozone, tends to create a lot of cooling, cold stratosphere. In fact, most of the time when you have a solar max, a lot of people try to connect solar activity to individual storms. That's the wrong way to do it. Anyone that does that is BS. What you want to do is that when you have an active solar environment, it leads to a cooling of the stratosphere overall, right? And because of a colder stratosphere overall, you tend to have stronger polar vortexes in the stratosphere. So this is why when we have a solar minimum and you have basically a blank sun, no sunspots, that allows for a buildup of ozone in the stratosphere, leads to a warmer stratosphere overall, leads to a weaker polar vortex overall. That's the overall theme. The last time we saw that happen was the early 2010s. And we all remember what those winters were like. So, we're at the peak of this phase. So the fact that we see this cold stratospheric environment makes perfect sense. But let's go lower in the atmosphere. Let's go to 100 millibars, which, just to give you a reference point, is right down here. So let's see what's going on down there. Well, how about near record temperatures? Wow, that's kind of surprising, right? You would think, hey, look, we have plenty of solar activity. I mean, if you don't believe me, just take a look at the sky the past couple of weeks with the aurora, right? Clearly, we're seeing a lot of impact. But our stratospheric temperatures in the lower stratosphere are very warm. Warmer stratosphere leads to a disturbed, disrupted, sometimes warped polar vortex. The reasons for this warm stratospheric environment, in my opinion, has to be the influence of the water vapor that has been put into the stratosphere. Now, some people would likely point out climate change, but climate change doesn't work in this environment because the theory of climate change is such that the CO2 interacts with ozone and leads to a cooling, like what we're seeing in the upper stratosphere. And because of cooling, the stratosphere contracts, the troposphere expands, and that expansion leads to warmer temperatures, which leads to global warming. Okay? So this wouldn't work. If anyone tries to pull that on you, it doesn't work here. But the water vapor factor would. So when I consider this, when I worked on this with the forecast, I said to myself, you know, Stephen, there's going to be a displacement between what we're seeing at 50 millibars and what we're seeing in the upper troposphere in terms of the polar vortex. And what this tells me is that you're going to have periods where the polar vortex is going to get stretched. And when that happens, combined with what we're seeing with La Nina, that's going to lead to a very powerful ridge in the Gulf of Alaska. The question I have, which is really we're going to have to wait and see how this evolves, how frequently does that happen and how robust is that ridge? So that is something that really has caught my eye. And the other thing that has caught my eye at 10 millibars is that we're getting this persistent warm pocket setting up around the Bering Strait and around Alaska. And the reason why this really catches my eye is that when you transpose this and put this down towards the troposphere, so up here's the stratosphere at 10 millibars, here's the troposphere down here, right? So when you see this environment set up here, this typically leads to a nice upper level low or lower 500 millibar heights down towards the central Pacific. And this usually leads to robust above normal heights here and here. You're seeing a lot of below normal height potential here. Again, you don't take this one-to-one, but you kind of get the idea of where the environment's setting up. And you get support for below normal heights around the Aleutians and around the Bering Sea. So this really stands out to me as something where I would not be surprised, based on what I'm seeing here, that we get periods of some active winter weather. Now, whether or not that means snow for you, I'm not going to say. We'll dive into that in just a moment, what I'm thinking about as far as the pattern evolution. But this is not going to be a quiet winter with a zonal Pacific jet all winter. We'll see that at times, don't get me wrong. But that won't be the theme all winter based on what we're seeing. Now, as far as the snow advance for October, very impressive first half of the month. It's going to kind of level off. Probably end up near to slightly above normal. But the thing that really caught my eye is a change in Canada, where we went from well below to well above in the past couple of weeks. There's a lot of focus on the Siberian snowfall, and rightly so. It helps us understand the potential for above normal heights around Siberia that could disrupt the polar vortex and lead to better high latitude blocking regimes. And I think it'll be a minor factor. But what really caught my eye was what was going on in Canada. Why? That's our cold source. If we have below normal snowfall in northern Canada, it doesn't matter what type of 500 millibar pattern we have, because basically someone left the freezer door open and we have no more cold air left. So the fact that we're starting to see rapid snow growth and building and strengthening of polar and Arctic air masses here is very important. So we're starting to see that and really starting to see that evolve nicely here. I expect us to see more of an influence from polar and Arctic air masses probably mid-November, we'll probably really start to feel that influence. Enjoy the warm weather while you can. It's not going to last. And as my wife would say, as she has reminded me several times, this type of weather is the type of weather where when it flips, it's going to smack you hard. Right, honey?
Yeah, I'm waiting. I know what's going to happen.
Yep, we're well prepared. So enjoy this while you can. So this really stands out to me as something very interesting. Really stands out as something that really catches my eye. The other thing that catches my eye is a well below normal sea ice here in the Arctic. Now, it's grown over the past couple of weeks, which you would expect, but this type of below normal sea ice value would increase the potential for disruption of the polar vortex, or at the very least, displacement. So basically, all of these observations that I'm seeing here, they support displacement and stretching. If you're looking for a split of the polar vortex, it's not happening this year. Excuse me. If you're looking for a wind reversal like last year, it's not happening this year. Not with a positive QBO. Stretching, displacement, polar vortex gets displaced towards North America or stretches toward North America. Totally in the books. Totally in the cards. Splitting, no. So, with that, this is the general idea of the winter forecast. Got nice maps. I'm getting better graphically, which I'm very, very proud of. And look, I even put the CDM seal in there. Very, very proud of that, right? Okay, so what does this all mean? Well, with a La Nina influence, I'm not going to say dominant, but with a La Nina influence, there are certain storm tracks you can expect. Much like with an El Nino influence. In El Nino, you can get a lot of storms coming out of the Gulf of Mexico. And you get a lot of storms redeveloping off the coast because of that. La Nina is more displaced further to the northwest. One track that's going to be dominant is track number 1, which is your traditional clipper. Most of these clippers are going to be very weak. 1 to 2 inches of snow in the coldest environment. They're going to be the type of air masses where they transport that polar air mass into the region. The bulk of your snowfall with these storms are going to be more in the upper Midwest. And then as they approach the mid-Atlantic, most of them are going to weaken. But every so often, if you get a negative NAO to pop at the right time, they can drop a nice little moderate snowfall over the northern mid-Atlantic. I think that we'll see a lot more of these clippers. The other storm track is 2 and 3 that I think we're going to see a lot. 2 is your traditional lake color. This is when you have a trough building into the west and you have a positive NAO. I expect to see this several times this year. This is going to lead to mostly rainfall for much of the region, which frankly we need it. But all your cold air is locked back here. And then typically what happens behind this, you get your Arctic air rushing in. But behind number 2 is typically when we set up number 3. Number 3 is your Miller B type storm. This is where you get a storm track developing around Oklahoma. It tracks towards the Tennessee River Valley. And then depending on your high latitude blocking, you either go to 3A or 3B. 3A is where you don't have blocking, right? High pressure's off the coast. You have what's called a positive NAO. And your storm track basically cuts through Pennsylvania. This is a very icy storm type pattern for the Poconos, the Catskills, the Hudson River Valley, and New England. Possibly a good burst of snow at the initial start over the interior. Where, like, let's say you pick up 4 to 8 inches of snow, half an inch of ice, and then it goes over the rain. The coastal plain in this type of track, typically you might start off with a burst of snow, picking up 1 or 2 inches, and then it changes over to rain. 3B is far more interesting and more of a pain in the neck. because 3B depends on how fast does the low transition from the interior to the coastal plain. So what you'll typically get is a low pressure system, a warm front, and then another low pressure system. And the speed of the transition will tell you whether or not your coastal plain is going to go from snow to rain and then back to snow, or go to snow and a wintry mix. A lot of it's going to depend just how strong your high pressure system is with cold air damming. This is your wintry mix mess on the coastal plain and your heavy snowfall for the Poconos and Catskills. The more we see a negative NAO pattern, the more we'll see 3B. Can 3B produce a widespread heavy snowfall event? Yes, if the transition towards the coast is faster. How many times that happened? I have no idea. We're going to just watch and see how the pattern evolves. And quite frankly, the theme of our winter. Look, some winters you have a theme where the transition takes longer. Sometimes you get themes where it moves faster. It really kind of depends on the mechanisms going on in the atmosphere within the pattern that we're in. Number 4, well, this is my special one. This is the type of storm track where, well, people write history books about. Like the 1979 blizzard, President's Day blizzard. Well, that's very special for my wife, right? Yep. The one she was born in. And the one I did a research paper on. This is the President's Day storm track. What this basically is where you get a polar or Arctic air mass dropping south, the frontal boundary stalls out, subtropical jet stream remains active, you get waves of low pressure and moisture riding up along that frontal boundary, and you end up with a robust snowstorm. This is going to be the least frequent one, but it is possible. It is the type of storm track and storm that can change the theme of your winter. From, we had some snow, to, wow, we had some snow. So this is a storm track that I think, because of what I'm seeing with the strong ridge in the Gulf of Alaska and the potential for at least transient negative NAO pattern, that this could be a wild card this winter that we'll really have to watch out for. The first key will be to determine how far south these polar and Arctic air masses get. And the best potential for storm track number 4 is going to be early January to mid-February. The best potential for these other storm tracks basically is going to start in mid-December and continue on through mid-February. But for track number 4, it's going to be a January-February type setup. So what to expect overall? Well, let me break down the zones. I have them written right here. Excuse me. Okay, so forecast zone 1. This is your interior. For some of you guys who love skiing, this is going to be a good year for New England. Those of you who love lake effect snow, good time for you in the eastern Great Lakes. The combination of storm tracks will support several snow events, strong lake effect snow events, longer periods of below freezing days. Temperatures will average near to slightly below normal, and precipitation will average about near normal to slightly above normal. Snowfall will be above normal in those zones. Zone number 2. This region will be closer to the mean storm track, but on the cold side of that storm track. So many of the storms will feature snow mixed into sleet and freezing rain. Temperatures will average near normal, precipitation near normal. Snow accumulation will be near to slightly above normal. Zone 2 is where storm track 3B and 4 can significantly increase the potential of above normal snowfall. Zone 3 is my wild card zone. Wouldn't you know it, right around the I-95 zone. Storm track number 4 will make or break the winter in zone 3. 3B, you'll get your moderate snowfalls out of this. This region will be closer to storm track, but again, most likely on the warm side, especially if you're looking for a transition zone when we see a storm transitioning towards the coast. Temperatures are averaged near to slightly above normal. Precipitation near normal. Snowfall accumulation will be near normal to slightly below normal. If we see that storm track 4 take shape with a sustained negative NAO pattern established, it could more likely end up above normal. It's a huge wild card there. Zone 4 is the easiest zone for me to forecast for. The region will feature most storm tracks to the west of the region or over the region. You're going to have the best potential for your frozen precipitation to the north of you. You're going to end up with above normal temperatures for the winter, above normal precipitation, which we need, but below normal snowfall. Even with, if we get a storm track 4, it's really going to have to push the envelope to end up with above normal snowfall in this region. But it could push us to near normal. So if you're in zone 4, not the best winter for you. Zones 2 and 3, there's some potential. Zone 1, game on. If you're looking for snow, you want to be in zone 1. So this year, the bulk of the winter storms will feature precipitation events with multiple precipitation types, a lot of changeover timing challenges. Many storms will feature precipitation that will start as snow and then change over to some sort of sleet and rain. The best potential for heavier snowfall obviously is going to be over the interior. Key phrase to remember: easterly winds kill. If you have an easterly wind at your location, pack it up. It's over. So a couple things that could go wrong. Number 1, La Nina ends up stronger. Not likely to happen, but if it did, it would lead to a weaker subtropical jet stream, a more robust ridge over the southeast, and a storm track focused over the Great Lakes. Number 2, which may be even more likely, La Nina fails to form. In this case, both the polar and subtropical jet streams are equally amplified, and a colder storm track would focus along the coast or over the coastal waters, and also it would produce a more significant snowfall potential this winter. So that's if La Nina does not establish itself. Number 3, the NAO goes negative more often than not. In this environment with a positive QBO, it's harder to pull off, but it is possible. A negative NAO forms and breaks down repeatedly, producing several Miller-B-type storms for the region with more snow and ice and a colder solution overall. And then number 4, the NAO stays more positive because of the positive QBO. We get a few random negative NAO phases, but in this environment, the storm track more likely remains over the interior. We get a weak coastal low, leads to more ice potential over the interior, rain on the coast. So that is the winter forecast. If you have questions about the forecast for this week, it's going to be dry. Not much going on. And for you Yankee fans out there, all the games at home, I expect the Yankees in 4. But if it gets to a game 5, no significant weather impacts at Yankee Stadium for games 3 through 5. Now with that, I will attempt to answer as many questions as I can before I lose my voice. So as you can see, winter is not canceled. Andrew. Let's see here. Rip-roaring subtropical jet at 215 millibars. Yes. Yeah, that really stands out to me. When you study for a La Nina, you tend to look for a very weak subtropical jet stream. We're trending in that direction. It's not really showing up this year. It has me concerned that that's being missed. And quite frankly, I hope it does remain active, because that means maybe we can get some more steady rainfall events up here. Massive cold air over Siberia and Arctic. Of course, the 10 millibars vortex is over towards Russia. 70 millibars, sort of, but it is so large, it pretty much all over the place. We're still developing our polar vortex. But overall, I think that it's going to be a very interesting year to see where that gets displaced. Are they the same people going back adjusting temperatures from a century ago? I don't. Not too many temperature. I've heard of this rumor of people adjusting temperatures. Where you have some temperature adjustment in the climate records is due to some error analysis. Some of it is legitimate. Some of it is not, especially if you're looking at some of the foreign ones. But overall, it's not it's a process that's improving compared to what we were seeing in the early 2000s. What are the chances this La Nina basically collapses into a neutral state? I think it's possible based on what we're seeing. I mean, look, this La Nina was supposed to be in place in June. Still hasn't gotten its act together. And typically La Ninas peak in December. So the clock is ticking. There's a huge temperature difference in the northern Pacific. Could that itself drive a persistent upper level low? And if so, is it something that would wobble back and forth? It's kind of like a gatekeeper. Yes, exactly. The evolution of the interaction between the upper level low around the Aleutians and northern Atlantic and northern Pacific and the upper level ridge in the Gulf of Alaska is going to be a traffic cop for what happens over the eastern United States for this winter. When the ridge builds in the Gulf of Alaska, the cold air is coming. I think the time frame is simply way too short in a way of observations of any conclusive regarding climate change. No, I would answer this very carefully. It's not too short in terms of understanding the trends. For example, the acceleration point. For those that run around saying that the world's going to end or any of that nonsense, yeah, it's ridiculous. We've been a lot warmer in the past. The only problem is that, look, guys, I don't know about you, but I don't want tropical plants in New Jersey. And I don't want to live in the same environment as the dinosaurs because I sweat too much and I'm Italian. So I would prefer not for that to happen. I would like our temperate zones. So we don't want to get that warm either. Almost running out of tea. I've tried every cough drop known to man. Trust me, I'm trying everything. Seems once again, as far as chances of cold and wintry weather, it's a polar vortex location. Partially, yes. That is definitely part of the equation. Let's see here. It seems the past couple of La Ninas do not give us the clippers that one would expect. That's true, but a lot of those La Ninas were central west based rather than central east based. So we'll see whether that continues. The 1979 President's Day storm is famous almost also because the trailing cold front delayed the start of the first full race of live broadcast of Daytona 500. That was a thing back then. They still do that? I don't know. Yeah. They were so desperate to keep the snowing audience in the north, they stayed the race under yellow flag. Huh. I did not know that. Interesting. Let's see. Excuse me. What we have in social media. Holy crap. Holy smokes. I just checked YouTube. Yep. Wow. Let's see here. Will we get more snowfall this year? Let's see. I'm not entirely... this is from EPAWA Weather Consulting. One of the guys I know very well. I'm not entirely convinced that a weak La Nina is reached. Understandable, absolutely. Wouldn't at all be surprised to see it remain positive and so neutral, say minus 0.4 degrees Celsius in the ONI. I think that is possible. Absolutely. I could definitely see that being a thing. Let's see here. Let's see. Could a more neutral ENSO help suppress the southeast ridge? Yeah, a neutral ENSO environment would lead to more interaction between the polar and subtropical jet streams and more phasing potential between the Tennessee River Valley and the mid-Atlantic coast. It would certainly lead to stormier conditions. Let's see here. The cold front next. Excuse me.
Drink some tea, babe.
Oh, I am. I'm almost out.
You want me to make you another cup?
Yeah. Let's see here. Do you think the cold front next week comes Thursday night, or does the warmth potentially stick around into the early weekend? I don't think we'll see a significant drop in temperatures until mid-November. I think the cold fronts that move through are pretty weak. What's the media and politicians associating fossil? Okay, all right. I bet there is not one dynamic meteorology textbook that states that. Well, in a way, they do. And that's actually a good question. Do the aspects of climate change stand out in dynamic meteorology? And if you study the equations, I mean, really dive into the calculus, it actually does. Because what you're doing with increasing CO2, okay, is that you're altering the chemistry in the atmosphere. And as altering the chemistry in the atmosphere, you alter the thermodynamic equation, which is part of dynamic meteorology. Now, I'm not going to get into political nonsense here because I'm not running for president. And if I was, I'd beat everybody. So it's not fair to anyone else. But I will say this. Sometimes you have to make it very simple. If you put something into a system, you will get a response out. If you increase a component in the atmosphere, there will be an equal opposite reaction. That's the most basic physics I can give you. With that said, no, the world is not going to blow up. The Earth is going to be fine. We may not be, but the Earth is going to be fine. Do you think Philly will have more or less snowfall than last year? I think everyone has the potential of seeing about the same or maybe a little bit more than last year. Especially if we get track 4. Is there anything on X? Uh-oh, we have stuff on X. I knew this was going to be a busy night.
Yeah. I mean, sorry, I gotta hop around a little bit.
Let's see here. I'd like to hear your opinion about the possibly staying ENSO neutral. Okay, so in fact, here, hold it. Let me see if I can find data on this. Let's see here. No. Okay. Give me 1 second, because I got a chart here that really stands out to me. Here we are. Okay, so let's talk about ENSO and neutrality. So, when I'm studying for a La Nina, I want to study the subsurface, which is what this is, right? In this environment, this signal does not give me a lot of confidence that we're going to have a robust La Nina. I think we stay cold. These anomalies here certainly support below normal temperatures in the eastern and central zones. But look how much warming is starting to develop out here. over the past couple of weeks. And typically when I'm looking for a robust La Nina signal, I want to see a lot more warmer water out here. We're not really seeing it. This is a signal of either weak or neutral. And if that continues, then what you're basically going to end up with is a lot more interaction between your subtropical and polar jet stream. Your subtropical jet stream is going to be more active, and you're going to have potential for more polar air masses being able to push further south. This does not guarantee winter storms, though, because again, we have to work out the high latitude blocking regime aspect.
That just came through. I'm gonna upload Facebook.
Typically, La Ninas and neutral years typically see more of a front end start to the winter. I like the idea of the bulk of our winter action is going to be from mid-December to mid-February. I think that's a good measurement. And in terms of our best potential storms, early January through mid-February. And for those of you talking about white Christmas ideas, always remember, even in the best conditions, it's only a 10% chance. So there's that as well. Any...
Okay.
Holy smokes, let's see here. Hope you feel better. I'm trying. Let's see here.
I'm trying to get them better.
El Nina is stronger than El Nino, more snow. You mean La Nina. Okay, when you have an A in Spanish, it's La Nina.
La Nina and
Yeah.
El Nino. Yep.
Let's see here. What snow thing am I staying in Hudson River Valley? We're not going to do in my backyard questions, but if you're in zone 1, you should be very happy, which a lot of Hudson River Valley is. Does everything have to line up perfectly this year for blockbuster blizzards? Yes. Any blizzard. Any blizzard that you have ever read about or experienced has evolved because the environment was perfect. Blizzards are rare. They really are. Major winter storms like the blockbuster winters we saw like around 2010, that's an anomaly. That's not normal. So yes, everything has to line up just right for those type of storms, which is why they're so exciting. Anything else?
That was the rest of it. I didn't see that it had a drop down thing. That's the rest of it.
My little 8-year-old would want...
They want to skip Blizzard.
I get it. Yes. Believe me, you're talking to someone that used to annoy my parents because I would open up my garage door and sit and watch the snowflakes fall and wait for the rain to change over to snow. So I get it. I totally get it. Yes, it has to be nearly perfect. It really, really does. But that doesn't mean it can't happen. And at 8 years old, you know, a 6-inch snowfall is still a lot of fun too.
Below that.
Do you account for geothermal in the oceans? Oh, you mean volcanoes? Oh, absolutely. I mean, part of that is what we were talking about with Tonga and the water vapor in the stratosphere. Those are all factors. Look, there's a lot of causations for what's going on in the world's oceans. Lots of activity. But at the end of the day, to me, what I'm studying is the thermal gradient, not necessarily the cause, right? Because that's what's important to me when I'm doing my forecasting. What are the factors that influence the MJO? Mountain torque, convection development, the AMO. I'm sorry, not the AMO. The oh man, I just went blank. Angular atmospheric momentum, AAM. Sorry, that's a factor as well. So yeah, when we're talking about angular, again, when we're talking about MJO waves and stuff like that, we're talking in the scale of meters per second a lot of times. So it's not something that is huge. It's kind of like that term, a butterfly flaps its wings.
Yeah.
It's kind of not that far off from that. All right. And look at that. I've answered plenty of questions. I haven't dropped dead from
That's somewhere
coughing.
on YouTube, that's not
Yeah, the reason why I don't mention Miller A storms this year is that's typically more of a El Nino environment. Miller A's are more frequent in El Nino years. Miller B's are more frequent in La Nina years. The reason why is because of the placement of the jet stream dynamics. Typically, you don't get a lot of storms coming out of the eastern Gulf during La Nina. That's usually more of an El Nino environment because you typically have below normal heights over to the southeast. In El Nino, in La Nina, you typically have above normal heights around Florida and the Bahamas. What happens if we don't get rain next 15 days? Will we break a record? And quite frankly, I'm not expecting much in the way of rain over the next 15 days, unfortunately. Is the PDO the strongest signal for the Mid-Atlantic? Not the strongest, but it's an important signal. When you're doing seasonal forecasting, or any forecasting really, the worst thing you could do is just focus on what's around your neck of the woods. You want to look all the way through the Pacific. So that way you get a better idea of what's influencing the pattern coming in. Let's see here. And with that, it's after 9 o'clock. And I think I've answered plenty of questions. As always, outstanding job, everyone. I want to thank my wife for helping me out with the tea and the honey. And I would not have been able to get through this without her. So as always, thank you, honey.
Of course, honey. I love you.
Doing a great job as always. So we answered all the questions. We talked about winter. Let me wrap this up before I start going on a coffee fit with this. Do not cancel winter because it will slap you in the face. Do not get overexcited with GFS 15-day forecasts that will produce 16, 17, 25, 30 inches of snow that some idiot will post on social media. If you want to keep your sanity this winter, the best way to go about this, and the way that I will be forecasting, is 7 to 10 days out is where we look at potential. 5 to 7 days out, we narrow down the zones of impact. 3 to 5 days out, we start adding details. 1 to 3 days out, we put out snow maps and start talking about snowfall totals. If you go with that process, you will most likely keep more hair than I have. And you won't get caught up in a lot of this hype and disappointment. La Nina winters typically feature a lot of wintry mixed precipitation events. Prepare accordingly. And I do expect some wild cards and some surprises this year. Now it's just a matter of just keeping an eye open. Keep an eye on the ridge in the Gulf of Alaska. That is the bellwether. That is your signal. When that ridge builds, that's when the fun begins. And I think that answers everything for tonight. Thank you again for joining us with this winter forecast. And next week, we will not have a live chat because we will be celebrating our wedding anniversary. But we'll have the live chat the week after. So, happy Halloween. And as always, stay safe out there.